70 years is the remarkable age of a technology that continues to exist almost entirely unchanged, despite the dominance of digital data on phones and cloud servers. Why does the vinyl record persist in an era of invisible numbers? It would seem that modern storage would render physical discs obsolete, but inside the factory, music undergoes a transformation where it ceases to be code and becomes a tangible physical structure. One can notice how the equipment gradually prepares the raw material for this transition. Tiny vinyl pellets are fed into the system, where they are heated until the polymer loses its solid form. This process continues until the material melts into a soft, malleable mass known as a biscuit. It only looks obvious that the plastic must be melted, but in reality, the temperature must be controlled with jewelry-like precision to ensure the disc remains durable. But this is just the beginning. The softened mass is positioned between two heavy metal stampers, which are engraved with the entire recording in the form of a continuous spiral. Enormous pressure is applied as the hydraulic press closes the gap between the stampers in a single, powerful movement. In just a few seconds, millions of microscopic sound grooves are imprinted directly onto the surface of the cooling disc. It is visible how the cooling lines and hydraulics work in tandem to set the shape before the pressure is released. Everything only gets more complicated as the excess plastic is trimmed from the edges while the disc is still warm. The process is only gaining momentum as the invisible piece of music is finally transformed into a physical record that can truly spin on a turntable. The material leaves the press, transitioning into a calm stage of inspection and packaging. 40 million units per year. That is the staggering scale of vinyl record sales in the United States alone. Why does a mechanical format more than half a century old continue to thrive in a digital era? It would seem that modern convenience should have rendered the spinning disc obsolete, but in reality, vinyl has recently surpassed compact discs in sales for the first time in several decades. Many listeners remain convinced that the physical nature of the medium provides a warmer, deeper, and more natural character than any digital alternative. The secret lies in a tiny stylus that travels along an ultra-fine spiral groove engraved directly into the surface of the disc. Because the sound is reproduced through physical contact, the storage method is entirely mechanical. Microscopic waves within that groove cause the stylus to vibrate at high frequencies. One can notice how an amplification system then converts these precise vibrations into electrical audio signals for the speakers. But this is just the beginning. The journey of a vinyl record begins in the mastering room, where the music is carefully prepared to match the physical constraints of the format. Unlike digital platforms, sound on vinyl exists only as a physical structure carved into the disc surface. Why is the recording adjusted with such extreme care before the first groove is ever cut? The engineering must be perfect so the stylus can travel smoothly without jumping. If the physical waves are too aggressive, the needle will lose contact with the groove and ruin the playback experience. Everything starts when the mastering engineer receives the final mix from the recording studio. This source material is typically delivered as a high-resolution file at 24 bits and 96 kilohertz or even higher. The equipment gradually analyzes the entire track for frequency range, overall loudness, and the nuances of dynamic range. Frequencies that are too strong, especially very low bass occurring below 40 Hz, can cause the groove to become too wide. This instability makes the stylus wobble during playback. To prevent this, engineers usually apply high-pass filtering to remove those extremely low frequencies entirely. They also convert the stereo bass into a mono signal so the groove remains physically stable beneath the needle. It is visible how the technical limitations of the plastic define the very sound of the music. And this is not the limit. Another critical standard in the preparation of the master is the RIAA pre-emphasis curve. During the mastering phase, low frequencies are intentionally reduced while higher frequencies are boosted. It only looks obvious to record the sound as it is, but in reality, this equalization is vital. During playback, the RIAA circuit inside the amplifier reverses this process, which helps reduce surface noise and preserves the fine details of the high-end audio. Engineers must also calculate the duration of each side of the record with absolute precision. For a 12-inch disc rotating at 33 1/3 revolutions per minute, each side typically holds about 18 to 22 minutes of music. This duration is selected to maintain the strongest possible audio quality across the entire surface. If the duration becomes longer, the grooves must be packed closer together, which reduces the signal amplitude. The process is only gaining momentum as the parameters are finalized. When the music exceeds 22 minutes, the resulting sound becomes noticeably weaker and quieter. Once every technical parameter has been optimized, the final master is exported as an analog signal or a high-resolution file. The camera glides along the specialized cutting system that receives this audio. This machine transforms the sound directly into physical grooves on a lacquer disc, beginning the transformation from data to matter. From here, the transformation moves to the next phase of processing. 100% of the audio signal must be converted into a physical medium once the master file reaches its final optimization. Why is this transition from digital or magnetic energy to a physical object considered the most sensitive point of production? This stage demands the mechanical engraving of the sound wave directly into solid material, creating a permanent structural record of the frequency. One can notice how the engineer prepares the cutting lathe, a high-precision machine designed to translate electrical impulses into mechanical motion. But this is just the beginning. An aluminum disc coated in a layer of soft, dark lacquer is placed onto the high-precision turntable. The equipment gradually brings the disc to a constant rotation speed of exactly 33 1/3 or 45 revolutions per minute. A cutting head equipped with a stylus made of diamond or sapphire begins its descent toward the spinning surface. It looks outwardly simple, but in reality, the stylus must vibrate with microscopic accuracy to mirror the incoming audio signal. Each lateral movement of the stylus, shifting from side to side by only a few microns, carves a continuous spiral groove from the outer edge toward the center. These microscopic physical ridges carry the entirety of the musical information. The process is only gaining momentum. When a playback needle later follows this exact path, it will recreate these specific vibrations to produce sound once again. The control system ceaselessly calculates the necessary distance between each pass of the spiral. Greater energy in louder musical sections requires the stylus to move more aggressively, necessitating wider grooves to prevent overlapping. Conversely, quieter passages allow the grooves to be placed much closer together, which optimizes the available surface area on the disc. The camera glides along the surface where the first physical foundation of the record is being formed. It gets more complex further on. The result of this precision engraving is the lacquer master, the primary disc containing the entire composition in physical form. Every depth and curve of the groove is measured in units smaller than a human hair. After the cutting head completes its path, the surface requires immediate purification. It is visible how the stylus produces tiny fragments known as lacquer chips during the engraving process. Deionized water and a mild cleaning solution are used to wash the disc thoroughly. This removes all traces of dust, oils, and microscopic debris that could interfere with the chemical integrity of the next stage. The equipment ensures that every micron of the groove is clear before the lacquer master proceeds to the electroplating department. The first physical manifestation of the sound is now complete and ready for the transformation into metal. 100 nanometers is the approximate thickness of the precious metal film that soon covers the entire surface of the disc. Why can technicians not simply plate metal directly onto the clean and dry lacquer coating? The lacquer material itself is an electrical insulator, making it impossible for a plating current to pass through without a conductive bridge. A specialized solution containing silver nitrate is sprayed onto the revolving surface to solve this technical barrier. A chemical reaction occurs almost immediately as the liquid contacts the lacquer. One can notice how silver ions precipitate to form an ultra-thin metallic layer that clings to every microscopic peak and valley of the audio grooves. But this is just the beginning. The silver layer only looks obvious and simple, but in reality, it must maintain absolute continuity while being only a few dozen nanometers thick. The audio grooves themselves measure between 1 and 2 microns in depth, requiring the silver to settle with molecular precision. If the coating is uneven or interrupted by a single gap, the subsequent metal stamper will carry permanent defects. The process is only gaining momentum as the lacquer surface transforms into a continuous conductive metal layer. This chemical transition prepares the disc for the nickel electroplating stage, which will eventually form the heavy mold used to press vinyl records. Transition to the next level. 300 to 400 microns is the final thickness the nickel layer must reach to achieve structural integrity. The conductive silver-coated disc is mounted onto a rotating shaft and submerged into a deep bath filled with a nickel sulfate solution. It is visible how the equipment gradually lowers the disc into the chemical mixture to begin the electrolytic transfer. Why is the rotation of the disc strictly maintained throughout the submersion? Constant movement ensures that the metal ions distribute themselves with perfect uniformity. When an electric current flows through the sulfate solution, nickel ions begin depositing onto the silver film, replicating the intricate shape of the audio grooves with absolute fidelity. The process progresses slowly under the rigid control of temperature, electrical current, and rotation speed to ensure the metal grows at a steady rate. At first glance, it seems the metal forms quickly, but in reality, the deposition requires many hours of constant monitoring. The nickel layer eventually thickens until it becomes a solid, independent plate capable of being separated from the original lacquer. This primary metal plate is identified as the metal father, and it carries a negative impression of the soundtracks. The process does not end at this stage. From the metal father, further electroplating cycles are initiated to create additional components for the production line. A positive copy, known technically as the metal mother, is produced first through the same electrolytic principle. Further plating of the mother then creates the stamper, which serves as the final metal mold for the factory floor. Before the stamper can be utilized, it undergoes mechanical finishing, where the edges are trimmed and a center hole is precisely machined. The camera glides along the polished surface of the finished mold as it is prepared for mounting inside the pressing machine. This metal stamper will ultimately shape the audio grooves onto thousands of vinyl records during the final manufacturing phase. The molten plastic will soon meet this cold metal surface to receive the imprint of the sound. 130 to 180 grams is the standard weight of the material mass that eventually transforms into a 12-inch vinyl record. Why is the composition of this substance so strictly controlled during the pre-pressing stage? At first glance, it looks like a simple plastic preparation, but in reality, the chemical balance determines whether the audio grooves will retain the intricate details of the sound wave. The process begins with the preparation of polyvinyl chloride, or PVC, which serves as the primary thermoplastic foundation for the medium. The process is only gaining momentum. Polyvinyl chloride in the form of fine powder or small pellets enters the mixing system to be combined with specific additives. One can notice how the white base material changes when carbon black is introduced into the chamber. This crucial compound does more than provide the traditional black aesthetic. It significantly enhances the mechanical strength of the polymer while reducing static electricity. Consequently, this helps to minimize surface noise that could otherwise interfere with the playback quality. Thermal stabilizers and specialized lubricants are often introduced to ensure the heated substance flows with maximum efficiency. Everything only gets more complicated as the mixture moves into the mechanical mixing unit. Here, the material is subjected to temperatures reaching approximately 300 degrees Fahrenheit. Under this intense heat, combined with high pressure and the constant rotational motion of the central mixing shaft, the plastic particles begin to soften and fuse. The equipment gradually eliminates trapped air pockets that might otherwise create surface defects or structural weaknesses. It is visible how the material transitions from a fragmented state into a uniform, flexible mass through this continuous mechanical kneading. This phase ensures that the final product will be homogeneous and free of internal voids. But this is just the beginning. The softened polymer is compressed into a thick, rounded shape known technically as a vinyl puck or a vinyl biscuit. In this heated and highly pliable condition, the material is prepared for its transition to the pressing station. One can notice how the puck maintains its thermal energy to ensure it remains workable for the final formation of the grooves. The molten mass is now perfectly conditioned to receive the microscopic impressions from the metal stampers. The material leaves the preparation unit, transitioning into the final pressing stage where the audio will be physically etched into its surface. 100 tons of force is the immense pressure applied by the hydraulic system to shape the heated vinyl. Why is such a colossal load necessary for a material that has already reached a flexible state? At first glance, the vinyl puck seems soft enough to mold with much less effort, but in reality, this pressure is required to ensure the PVC fills every microscopic crevice of the audio grooves. The material is transferred into the pressing machine only after reaching its optimal temperature. It does not end at this stage. Two metal molds, known as stampers, are mounted facing each other inside the heavy press. These components carry the complete and intricate structure of the audio grooves, which were previously replicated from the lacquer master using the electroforming process. Before the pressing cycle begins, two center paper labels are placed onto the surface of each stamper. One can notice how these labels display the album title, artist name, track list, and markings for side A or side B. The paper is specially manufactured to withstand 300 degrees Fahrenheit without charring or tearing. Each label is carefully aligned with the center pin of the mold. This ensures the center hole remains perfectly positioned as the press closes. The labels are not glued. Instead, they are fused directly into the vinyl surface, becoming a permanent part of the physical record. Everything only gets more complicated as the mechanical cycle initiates. The heated vinyl puck is positioned precisely between the two stampers. The camera glides along the hydraulic cylinders as they descend with a steady, powerful motion. Hot steam circulates through the internal channels of the molds to maintain a temperature of exactly 300 degrees Fahrenheit. Under this combination of intense heat and 100 tons of pressure, the softened PVC spreads outward from the center toward the edges of the mold. It is visible how the hot material precisely copies the structure of the audio grooves engraved into the metal. These grooves are incredibly small, typically measuring between 1 and 2 microns in depth. Despite their microscopic size, they contain the entirety of the musical recording. The pressing cycle usually lasts between 25 and 30 seconds, but this is just the beginning. The hot steam is abruptly replaced with cooling water inside the molds. This causes the vinyl to harden quickly, which is essential to preserve the integrity of the delicate groove structure. One can notice the slight hiss of the thermal transition within the machine. When the press finally opens, the finished vinyl record is removed from the mold. At this stage, a thin ring of excess plastic remains around the outer edge. This excess material will be trimmed away during the following finishing step to create a smooth circular profile. The transformation of the raw puck into a functional medium is now complete. The material is ready to move to the next processing phase without haste. One thin ring of excess plastic remains around the outer edge after the vinyl record leaves the pressing machine. Why does this unwanted protrusion form on a disc that already contains a complete set of audio grooves? The material appears because the hot vinyl spread slightly beyond the boundaries of the mold during the intense pressure of the pressing cycle. But this is just the beginning. The disc must pass through a trimming stage to reach its final dimensions. One can notice how the record is transferred to a dedicated trimming machine, where a high-speed rotating blade removes the excess material around the entire perimeter. The cutting tool is precisely aligned to produce the correct diameter of the record, which is typically 12 inches, 10 inches, or 7 inches depending on the specific format. During this step, the edge of the record is also slightly rounded to prevent sharp edges that could damage record sleeves or cause minor cuts when handled by the user. Everything only gets more complicated. The removed plastic ring is collected, and in many factories, it can be ground down and reused in future production batches. Metal rods hold each disc slightly apart on cooling racks to stabilize their shape after the trimming process. It is visible how the records are placed so that air can circulate evenly around the surfaces. This allows the vinyl to cool gradually and maintain the precise microscopic groove structure after experiencing high heat and pressure inside the pressing machine. It gets more complex further on. Technicians perform a visual inspection to detect defects such as scratches, air bubbles, or dust trapped inside the grooves. They also look for uneven trimming or warped surfaces that would compromise playback. At first glance, the surface looks perfect, but in reality, some records are also test played on a reference turntable. This ensures the stylus tracks smoothly and the sound matches the original master recording exactly. Records that pass inspection proceed to packaging. Each disc is first placed into an inner sleeve, typically made of paper or anti-static material, to protect the grooves from dust and scratches. The record is then inserted into the printed album jacket, displaying artwork, artist information, and release details. Finally, the complete product is sealed in protective shrink wrap and packed into shipping cartons. The process is only gaining momentum as it moves toward distribution to record stores, distributors, and listeners around the world. From a piece of music recorded inside a studio, the journey of a vinyl record passes through a series of precise industrial steps. The original mix is first optimized during mastering, where the audio is carefully prepared for mechanical playback. The sound is then carved into microscopic grooves on a lacquer master disc, which is later transformed into metal molds through silver coating and nickel electroplating. These molds are installed inside a pressing machine, where heated polyvinyl chloride is compressed and shaped. This allows the tiny audio grooves to be replicated onto the surface of each record with extreme fidelity. After cooling, trimming, and careful quality inspection, every finished vinyl disc is packaged and prepared to reach listeners around the globe. Thus, the journey of the recorded sound from the studio to the physical medium concludes.